Coming up, we'll first of all look at the difference between alternating and direct current. Then we'll look at the purpose of inverters and where they are used. Then we'll move on and have a look at a simple example of how they work. And finally, we'll look at a more advanced pulse width modulation example. So what is an inverter? Well, let's start at the basics first of all. So you probably know that there are two types of electrical power in use, which are direct current, or DC for short, which is supplied by batteries and solar panels, etc. Now this type of power is mainly used by small digital goods with circuit boards, etc. The other type of power is alternating current, or AC. Now this is supplied from the power sockets in your homes, and this will typically be used to power larger appliances. Both of these types of power have their uses and limitations, so we'll often need to convert between the two to maximize their use. An inverter is a device which is used to convert between direct current DC and alternating current AC. If you use an oscilloscope to look at the signal of these two types of power, you will see that direct current sits at its maximum voltage and continues in a straight line. That's because its current flows directly in only one direction, which is why it's called direct current. If you looked at alternating current, you'll see a wave-like pattern where the voltage alternates between its two peak voltages in both the positive half and then through to the negative half of its cycle. This is because the current travels back and forth. So an inverter simply converts from direct current DC to alternating current AC, and this is a very useful invention. You can also convert from AC to DC using a rectifier, and it's common to find both of these in some devices. And we'll actually look at this in just a moment also. So where are inverters used? Well, a common and fairly simple application of inverters is within solar panels or photovoltaic arrays, as these generate DC power, but the appliances in your home will use AC power, so this needs to be converted for it to be of any use. You can also buy portable inverters for your car, which allow you to use the car's battery to power small household appliances. In this application, the inverter is coupled with a rectifier, and the AC power which comes in is converted to DC and then back to AC, but the controllers will change the frequency of the sine wave pattern. And by manipulating this, we can precisely control how the motor behaves. And when you join this to a fan or a compressor, etc., then you can precisely control how that performs also. So, how do they work? Well, let's consider a simplified circuit where the DC source is being used to power an AC load, represented by the lamp. To convert the DC to AC, we will use 4 switches. We will pair the switches together so that switches 2 and 3 open when 1 and 4 close, and vice versa. This will allow us to force the current through the AC load in an alternating direction so that the lamp will experience an alternating current even though it's from a DC source. So let's give that a try. If we leave switches 2 and 3 closed and then open switches 1 and 4, this will cause the current to flow through the right hand side of the lamp. If we then close switches 1 and 4 and open switches 2 and 3, this will force the current to flow through the left hand side of the lamp. So you can see that there is a direct current source, but the lamp experiences an alternating current. The lamp will not see this as a sine wave, however, as the sudden switching will only result in a square wave. The sharp corners of the square wave can be damaging to electrical equipment, so we need a way to smooth the corners out. The switching is also far too fast for a human to do.